Water is flowing continuously from a tap having an internal diameter 8 into 10 raised to minus 3 meter. The water velocity as it leaves the tap is 0.4 meter per second. The diameter of water stream at a distance 2 into 10 raised to minus 1 meter below the tap is close to. So over here we are considering that some amount of liquid is coming out from a tap. So take it as the cross-sectional area of tap over here is given as. So the the diameter is given. So the diameter at this point is given as, let's say, d1 is represented by 8 into 10 raised to minus 3. The water velocity as it leaves the tap is, the velocity of water over here, let's say it is given that v1 is 0.4 meter per second. The diameter of water stream at a distance, we know that as the liquid is coming out, due to the effect of gravity or the acceleration due to gravity, it is going to move with a constant. It is going to move with a constant acceleration, or its like area is going to decrease with respect to time or with respect to distance. And after some times, let's say the diameter becomes equal to d2, or area changes from a1 to a2. So our aim is to find out what about the value of this diameter over here, and the distance is given as nothing but 2 into 10 raised to minus 1, which we can take it as a 0.2 meter. So due to the effect of gravity, it is going to get accelerated. So the speed over here v2 will be greater than that of v1, and according to continuity equation, we know that as the value of velocity increases, area is going to decrease. So that's why there is a decrease in area or a decrease in diameter, because speed increases, area is going to decrease. So we can use continuity equation over here, and first, for that purpose, we should know the value of v2. First we can find out the value of v2 by using just normal kinematics equation, that is v square minus u square is equal to 2 into a into s. Over here, final velocity we take it as v2 square is equal to, we can take u square plus 2s, and u square is nothing but 0.4 square, that is 0.16, plus 2 into a is acceleration due to gravity, which we can take it as something but 10, into displacement over here is 0.2. So we can find out the value of this v2 square is equal to nothing but 0.16 plus 4, or you can write the value of v2 square is equal to 4.16. The root of v2 root of 4.16 will get us around 2.039, or you can approximately take it as 2.04 is a value of v2 over there. Now from this we can find out the value of d2 while applying continuity equation, that is a1 v1 is equal to, we can write a2 v2. So a1 we can take it as pi into, in terms of diameter, d1 square by 4, into velocity v1 is equal to, we can take it as a2 we can write it as something but pi into d2 square divided by 4 into velocity v2. So this pi by 4 and pi by 4 over here get cancelled. So we can find out what about the value of v2 over here. So we can write our d2 over here. So we can write d2 is equal to nothing but d1 square into v1 divided by v2. So you can write the value of this is the value of d2 square. So the value of d2 can be written as something but under root of this, or you can write d2 is equal to d1 into under root of v1 divided by v2. So the value of d1 is given in question as something but 8 into 10 raised to minus 3. So you can write this is 8 into 10 raised to minus 3 into under root of v1. v1 is given that 0.4 divided by v2, which we already calculated it as 2.04. So we'll get the value of d2 is equal to 8 into 10 raised to minus 3 into under root of 0.4 divided by 2.04, we'll get around 0.196, and root of this one will get around 0.44. So 8 into 0.44, you'll get around 3.54 into 10 raised to minus 6, or we can approximate it as 3.6 into 10 raised to minus 3.